Let's talk about something called as position vector. This set of video is the second part of your types of vector. So position vector, the name again itself is a giveaway for everything, pretty much everything. So what does position vector mean? Well, we have an example. We have a vector OA and OB pointing towards two different random points, but both are starting from a point which we know of. And so OA and OB are our position vectors. An example. So why is it a position vector? Because we know where exactly they're starting from. As simple as that. Okay, sometimes we have to draw position vectors wherein the data is in polar form. If you not come across this as of now, it will be there again in initial topics of mathematics in our higher grades. So wherein we have the angle and the length. This information, if it's given, we'll be able to draw the position vector. What does that mean? Let me show this. So say this is our x-axis and say this is our y-axis. And say we need to draw a position vector, say OP of length 4 centimeter and making an angle of 170 degree. When we know that this is a position vector, by default the 170 degree is always with reference to the x-axis. That's the funda. And then you draw the angle. So 3. So approximately this is what we're looking at. Point P, point O, this is 170 degree. This is 4 centimeter. Okay, so this is vector OP pointing towards point P, which is 4 centimeter away, making an angle of 170 degree. Right, guys? Next type of vector is polar vector. Example of that is a displacement vector. So let's talk about or see what is a polar vector. In specific, displacement vector. So we're considering the point A as initial point and point B as final point. So vector AB is our example of displacement vector because we don't need to have a definite starting point. It can be any random starting point. Okay. So you guys can put an example over here, same as this. I'm not going to draw that. Next, we have something called as finally an axial vector. Till now, all the things would have been simple and straightforward. This is where things are a bit confusing. This is known as a pseudo vector. Pseudo is false, right? So you will understand the reason behind this. These are vectors that represents rotational effect, very important. And they follow right hand screw rule. If you guys remember right hand thumb rule, it's the same as this. So basically hold your right hand pointing in the direction of your all the fingers other than thumb, pointing in the direction of the rotation. So this is your direction of rotation. So in this case this is clockwise, right? No, this is anti-clockwise. So holding the right hand in anti-clockwise direction, right? The thumb points in the upward direction, is it not? Again, hold your right hand such that your index, middle finger, then pinky finger and all of that, they are going in anti-clockwise direction. And the thumb points in the direction of, thumb points in the direction of sky. So thumb is pointing upwards. So here, the vector is in the direction of up. It's pointing up. Basically, the vector is pointing up. That's the right language. If it's in clockwise direction, the vector will be pointing down. Are you getting it? See, we're actually not pointing in the direction of where the force is acting or the velocity is taking place and so on and so forth. But we're just talking in terms of a pseudo direction, a false direction, wherein this object is not at all rotating in that direction, to be honest. But we make use of this concept and this has worked out. Okay. So it has worked out with calculations. It has worked out with the math and derivations and everything. Okay. So the actual vector is the only thing which is kind of confusing. If not, pretty much everything is simple and straightforward.